Continuing on with the experiment of the scientific method, we're now going to talk about the groups, which are the control and experimental. So first we have the control group, and your control group does not receive the independent variable. So your control group is not manipulated, and because it's not manipulated, it acts as a standard for comparison. So sometimes when you're referring to a control group, you may say what they're providing is a baseline of data. So this baseline of data is something for you to work from, something for you to compare your experimental results to. Not every experiment is going to have a control group, but most experiments that we would think about would need to have some type of baseline to work from, to know what the results should look like, to know how something does work. Um, this could be a flaw in an experiment is if they do not have that control group to provide that base of data to go by. The next group is the experimental group, which is also known as the test group. So this is your group of participants that does receive the independent variable. So they are manipulated by that one factor that you have decided to test. Now we're going to have two practices. So it's back on your back at the experiment section of your worksheet. And with this one, we're going to be identifying the control group is going to be pink, and the experimental group will be purple. So number one, music may help people relax. John got two groups of people together. He took everybody's pulse and blood pressure. Then he allowed one group to listen to soothing music while the other group sat in silence. After the song was over, he measured everyone's pulse and blood pressure again. So again, your control group, if you'll highlight it in pink, and your experimental group in purple. So you might want to pause the video at this time so you have time to work. And then when you resume, you'll see the answers. All right, so our control group here is our group is just sitting in silence. That's kind of what we do. We just, to relax or whatever else, we just kind of sit there. But our experimental group, what we're going to add to this is we're going to add soothing music. So the experimental group is a group of people who get the soothing music to see if that will help relax them a bit. And the way that we know if they're relaxed is we're going to check their pulse and blood pressure before and after. Okay, number two, preservatives like salt help keep food fresh. Katie made 12 loaves of bread using the same recipe and baking method. And 6 of them she used salt, and 6 of them she used no salt. After the loaves were baked, she placed each of the loaves in a plastic bag and left them close together on the counter in the kitchen. Each day she looked at them to see if any mold had started to grow. So control pink and experimental purple. So again, you might want to pause to give yourself a chance to work. And then when you resume, you'll see the answers. So preservatives are used to keep your food fresh and have been used in our area for a very long time as a preservative. So Virginia hams, we know how that are the salt cured hams. Um, so it's normal for us to put salt in order to preserve a food. What's not normal is for us to leave it out. And a lot of people are very serious about their salt intake because it may have an effect on your blood pressure. Um, so with this control and experimental group, it's actually having the additive, in this case salt, is the control group, is what you usually do. Not having it, not applying it, is what is the experiment. Okay, step 5 of your scientific method is your data. So data is information that you collect in the experiment. Now, this information, we've already seen this in our very first video we looked at of observation versus inference. It could be qualitative, so I have to describe it. The only way that I can give you this information is in words. So I could go out and do the experiment with the bees and say, oh, there were a few, or oh, there were several bees. Now, a few and several, a lot of times when you're using this descriptive data, several and few might mean different things to different people. So sometimes this might be what you want to stay away from, but sometimes you have to use it. So if I'm talking about cloud cover, partly cloudy, mostly cloudy, that's the best way that I have to describe that. Now, quantitative, numerical data, so talking about numbers. We could use some tools or we could just count. So this is much more of what we want to see in science. We want to see those numbers. So we've got 1, 2, 3 Diet Cola bees, and there's 8, 9, 10, 11 regular cola bees. So that's our numbers. So it's quantitative, quite quantities. Because it's not step 3, obviously. That's copy and paste error. So we're on step 6, which is the conclusion. And we're going to use our data from the experiment and we're going to look back at our hypothesis and decide to accept it or reject it. So are we good to go, or do we need to go back to the drawing board and tweak our hypothesis and start back over? Um, Now, when I looked at this again, I just counted those up. We had 11 bees visiting the regular cola and 3 the diet. My hypothesis was that they're going to like diet, but I was not right. Based upon the data here, the bees do not prefer the diet cola. They prefer the regular. And when you're doing the scientific method, this is pretty much where we're all going to stop. This is where we're going to end. Now, you get to college, or if you do something in science as your profession, you may get to this point and you're wrong, and you need to go back to your hypothesis. You need to go rework this thing. You're not just going to say, "Oh, well, too bad." So people who are working on the vaccine, if they don't get the results that they want to see, they're going to say, "Too bad, America. I give up." No, they're going to go back and they're going to work on things and go through this process again. Um, but usually the conclusion is where we're all going to kind of wrap this thing up.